Hello, my name is Maysam. This video is about a new concept called microcaching. In last 5 years, I was engaged with the concept of caching and the problem around it. After years and years of development and participating in different projects, I came to a model of caching which I call it microcaching. In this video, first I'm going to discuss about the problem of caching in general and challenges of caching in modern applications. I try to answer the following important question: why invalidation of cache is difficult and how to make it easy in your application. Probably you heard this famous quote by Phil Carlton: there are only two hard things in computer science, cache invalidation and naming things. But why cache invalidation is so hard? To answer this question, I need to start from ORM. I believe that the problem of cache invalidation has its roots in data models, not in the cache itself. As you can see later in this video, the difficulties of the invalidation of cache is because of an anti-pattern structure in our ORM data modeling. Or we can say the approach and pattern we are using to form our entity models has flaws. We are doing something wrong in modeling our data layer, which I believe is anti-pattern. I saw many different data models in different companies, and there are lots of examples and tutorials on internet about how to model the entities, how to connect them to an ORM like Entity Framework or NHibernate or any other ORM. I can say most of them have implemented this wrong pattern. But what is this pattern that I keep saying is a wrong one? Let me start with an example. Consider that your application has two entity models, foo and bar. You can see the foo has one foreign key of the bar inside itself. So in database world, we say that there is an association between foo and bar, which means that each foo has one related bar. When you set up an ORM, it will give you an option to load the bar object when you are loading the foo from the database. ORM will take the foreign key and fetch the data from the database and creates an object of the bar and put it into the foo object. So at the end, we have a foo object which has a bar object inside itself. This object inside the other object is the main evil in your data model. But why? Is it not nice that ORM is fetching the data of the bar for you? We can easily load the required data whenever it is required. This feature in ORM makes the life much easier. Yes, it is correct, but at the same time, it's very bad for cache-oriented design. Makes coupled model data and makes our application close to change in the future. These three topics that I listed here are now very vague. Let me draw a more clear picture. Let's assume that we want to cache our entity foo. What we have to do is read the data by our repository and put the data in cache. Now in the subsequent calls, we read the entity from the cache instead of the database. So our application is now faster because it will ignore lots of reads from the database. We know that the transactions with the database is one of the most expensive actions in terms of performance and speed. It is quite sensible to put the data into cache to ignore database calls. However, you have to consider that when we speak about the performance and speed, we are speaking about something relative because performance in different scenarios has different meaning. If you have a commercial website that has 10 visitors a day with normal actions like buying stuff from your website, then you don't need caching at all. But if you have a website which has 50,000 users in an hour, then you need a cache layer. And if you do not have a cache, then your application probably cannot handle the traffic properly. Okay, let's go back to the cache scenario. After putting the object foo in the cache, then in the subsequent calls, we are reading it from the cache. But when is the time to invalidate this cache? We know that we have a repository class for every entity in our application. One of the strategies that most of the developers are following is that in the repository, whenever the save changes of a DB context is called, they will invalidate the cached item, which is foo object here. Or they just invalidate foo object and wait for the next read call to cache the new foo object again. Because in the read, first we check that the object is in the cache or not. If it's not there, we read it from the DB and cache it. This seems very brilliant idea. So what's the problem then? Okay, now we are going to speak about the problem. The foo object here is the one that we are going to put in the cache. Foo has a bar ID of 2 and I put the object bar inside the foo so we can have a better visualization of the objects in the system. When you read the database and include the bar into your read, you will get an object like this foo, which has the bar in itself. In the previous slide, I considered that the repository is checking the item, whether it is in cache or not. But in real situation, because of the single responsibility and other solid principles, it's better to have a separate class that do the whole process. So you can see here, I have a class called foo persistory. This class has a repository in itself and first checks that the item is in cache or not. Then if it's not, it will call the foo repository at the object and then put it in the cache, and in the subsequent calls it's just go to the cache and bring the object for us. We now know that this foo object that you can see in the picture is in the cache. But if in other part of our system we update, delete or change the bar, you can see the disaster is happening. If I update the bar name to B, then my cache will be out of date because I am only invalidate the cached foo if the foo is changing, not the bar. So for the next time when I try to get the foo object from the persistory, it will load it from the cache and the bar inside the cache has the old value and our cache is out of date. The above scenario is summarized the whole cache invalidation problem. There is no way to know the bar has been updated. You can say I will keep a list of all foo objects which has the bar with the name A, and I will invalidate them all when the bar A is changing. But this is not a solution, because you can have a model like this which has lots of other objects inside it. Or you can have a data model like the picture in the right hand side, which has a chain of dependent objects. So you cannot keep a list of all the related objects and then check all of them whenever something is changing in the system. This is why I call this feature an anti-pattern, because it makes a data model that is coupled badly together. Software development is a new science and practice. For this reason, still they are investigating and experiencing new concepts and approaches. And still they are in the middle of a path of a long journey. For example, recently they come to this conclusion that microservices is the best architecture for big applications. Maybe later they find something else, who knows? And one of the concepts that has been practiced a lot and demonstrated that is very efficient is decoupling. In data, in services, in functionalities, or any component of an ecosystem. If you just look at the solid principle, you can see the first one, single responsibility, and the last one, dependency inversion, are about decoupling. Decoupled system is better and more efficient in comparison to the coupled one. The concept of decoupling is highly used in microservices architecture, and I can say one of the main reasons for microservices is to decouple the system, because decoupled system is easier to maintain, easier to expand, and easier to change. Nowadays, most of the dev teams are in the process of converting their monolithic apps to microservices, and if they are not in the actual process, they have a plan for it. And usually they have a big challenge in front of them. They have to decouple the functionalities and data in the current system, then convert those small islands, those small functionalities to separate services. So the first step is to decouple the data. If you look at the picture at the left hand side, you can see that we have a coupled system. And I'm emphasizing that this picture shows a coupled system, not just a coupled application. Application is just one kind of system. And you can see the components of this system are quite intertwined together. If we want to decouple the system, we can end up a picture similar to what we have at the left hand side. Similar and related components are gathered together to form a separate component of the system. So in this system, if I need to change the blue family functionalities, I know where to go and what to change. I can add more component to that family without any effects on the other components. In this way, I have a better maintenance. In this way, I have a better chance to expand my components in the future. Let's speak a little bit about the decoupling and the microservices. After working different development teams, you will see that most of them are in the process of converting their monolith architecture to microservices. I'm not saying all of them are right in this process or every monolithic application needs to convert to microservices. But this is another topic and I don't want to stay on that one. Let's assume that they need it. In this conversion, I mean the conversion of the monolithic to microservices, usually they have a very big challenge in front of them. They have to decouple the functionalities and data in the current system and convert them to small islands in the current application, and then they are able to convert those small islands to separate services. Then the first step is to decouple the data. But let's continue the cache problem, and we will come back to the decoupling later when I introduce a new data model, and then we will have a better picture of what I mean by decoupled data. Now I'm going to suggest a new solution for the cache and its invalidation. I call it micro-caching. I claim that we cannot have an efficient cache solution with the coupled data model. So first I need to change in my data model to be able to have a better and more efficient cache. And by efficient, I mean a cache which has always the latest and up-to-date data. For this purpose, my solution is to cache the smallest part of your data. Each model should be in the cache separately, and you can build up any long model out of these small micro pieces of data from the cache. And to achieve this, we need to have a decoupled data model. Let's go back to the foo and bar example to see what will happen to them in the new system. This is the old model, a foo object with a bar inside it. But in the micro-caching, we don't let the ORM fetch the bar object as an association in the foo object. Instead of that, in foo persistory, when we want to create the foo object, we read first the foo object from the cache or from the database, but the foo object that comes back from the cache or database has not the bar object inside it. For having the related bar object, foo persistory will call the bar persistory and asks for the bar object. As you can see in the picture, bar persistory, independent of the foo persistory, reads and caches the bar. That class fetches the bar from the cache or from the database, independent of the foo state. Then after that, the foo persistory will put the bar object in the foo and return it to the caller. In this model, whenever the bar is invalidated, the call to foo persistory will return a foo object with a correct and up-to-date bar inside it. Because the bar is always coming from the bar persistory, and bar persistory keeps the bar object up-to-date in the cache. So if at any time we update the bar name from A to B, the return object of the call to foo persistory will have the bar with the updated name. Here in this example, we can see how decoupling the data model will help us in invalidation of the cache. If you have a decoupled data models, then you are able to do the micro caching, means that you are able to cache every single entity independent of the other. Now you know what I mean by decoupled data model. In the traditional way, anywhere in your application when you have a lazy loading or you have the association objects inside other objects, you have coupled data models. Look at the picture on the left hand side. You can see that we have many repositories and any of them potentially can fetch data of the bar. We have one point of change but many points of reads. In this system, because the responsibility of the read of one entity is scattered around the system, you are not able to control the cache and the invalidation of the cache. But look at the picture at the right hand side. In this system, every other part of the system calls a single component to fetch the bar data. So we have one point of read and one point of change. Therefore, the responsibility of read and update are in one point. And this gives you the ability to cache and invalidate the cache effectively. Now that I have introduced the concept of micro-caching, I need to show you how this concept can actualize in a real application. In other words, I have to prove the concept. For this purpose, I've created a very basic application with ASP.NET MVC, which is just a basket and order management. The application is connecting via Entity Framework to Microsoft SQL Server to fetch and update data. First, we run this application without any caching, just direct access to MS SQL Server to see how our application is performing. We know that some facts can affect the performance of the application. Like if you host it on a very powerful server, then it will run faster. Or if you put the cache server and the host server on the same region or on a closed network, then you have less latency and faster response time. But here, for our purpose, it is not important what kind of VM is hosting our tests application or how powerful is the SQL server, because here we care about the differences in the same and identical environment. If our response time for a basket data retrieving action is 500 milliseconds, we want to know how much this action can be faster by adding micro-caching in the same environment. If we see improvement, I mean considerable improvement, then we can conclude with any configuration we will have much better performance after caching. But we have to have an effective cache, not just any cache. Okay, but how we are going to measure the performance of the changes? There are many softwares and techniques that help you to measure an application performance under the pressure. I will use MS performance testing to write some load testing in this proof of concept. Visual Studio performance testing is a powerful tool which is just enabled at Visual Studio Enterprise editions. But what is the load test? Load test is a performance test which shows you how your application will behave and react under high load pressure. For example, if you write an API and test it in your local and see that it takes about 100 milliseconds. This is not guaranteed that in high load production environment it will take same amount of time. I've seen many queries that took around 100 milliseconds with one user, but under pressure same query in same environment took about 5000 milliseconds or 5 seconds if you like. By load testing you can detect these bottlenecks of the application. Here in this proof of concept, I'm going to use the load test to compare the two applications, one with cache and another one without cache. And for caching, I will use Redis, which is one of the most popular distributed in-memory caching tools. This is the basic MVC application with identity for managing the usernames and logins. I have also added a couple of controllers and pages to this basic application. You can download this project from the link below the video, which is on GitHub. Let me first show you the whole application, which is just a couple of pages in the browser, and then we come back to the solution to see the backend layer. You can see here that I'm using the IIS, not the IIS Express. It's quite easy to set up your IIS to load your local websites. I cannot explain it in this video, but you can Google it and find lots of articles and tutorial about this. This is the first page, which shows the products here, and then the basket and mini basket. You can add any product into your basket, and in the mini basket you can see the number of items and values of those items in the whole basket. For keeping it simple, I am not updating the mini basket, but I'm updating the basket after user clicks on add button, like this one. So I will add more item into my basket. So you can see basket is updating itself. I have an option to proceed to checkout. So if I click here, the last page of the checkout will open. I have again the summary of the basket and a couple of information. Each of these sections coming from different tables. I wanted to have one view model that its data comes from different tables to mimic the more real scenario. If I click on this green button, I will place the order. And you can see I get the order confirmation. Now if I go back to my home page, the basket has been cleared and the situation has been reset to the first point. I have also another section called admin basket, which is just a simple page that contains a list of baskets, depending on which state of the basket are you choosing. We have three different states: one open, another one deleted, and another one completed. Open are those baskets that still is open and user didn't clear it or didn't conclude it. Deleted are those baskets that has been cleared by the user explicitly, and completed are those baskets that has been converted to an order. Okay, now let's go back to the solution to see the backend of the system. Here is my data layer, which I keep the data, domain, and view model. The data is that layer that we are connecting to database to fetch the data via entity framework. I have implemented unit of work and repository pattern, and here I have the repositories, and the abstraction is my interfaces. The next one is the domain project, in which I keep my entity, and there is also one view model. And what's this view model is exactly those view models that we are passing to our view or MVC views. And why I extracted them into separate projects is because to prevent the recursive references, we know that the services is responsible to create these view models, and the web is also need to use them. And also web has a reference to services because web is also using services. So if I keep the view model in any of these two projects, it will be a circular reference between these two layers, which is not allowed in .NET Word. For this reason, I extracted the view model into a separate project. Okay, here I have another layer which I call it dependency inject, but it's wrong, I have to call it dependency injection. I keep my AutoFac modules here in this project. I am using the AutoFac for dependency injection, but because this project is very small, so I have just one module and a bunch of services and repository that has been registered inside this module. When we are loading the first page, I'm in this page. the home controller will hit. The home controller has index action inside it, which is the default action of any controller. Let me open that one. Yeah, here is the index action, and in that one we call the basket service to get the view model that is required for the view of the home page. So let's go inside that one to see what we have. For the home page we need the shopping view model, and what is inside this shopping view model are three other different models which represent three sections of the home page: product, basket, and mini basket. And as you can see here, we have a basket view model, products, and mini basket. So each model of this view model represents one section of the home page. Yeah, product, basket, and mini basket. Let's go back to the controller and then do this one. You can see here I make a call to fetch basket data and products from the repositories, and then here I create all the three models. But you can see there is no call to the basket item repository, it's just calling to basket, get current basket of the basket repository. This is because when I fetch the basket data from a database with Entity Framework, I tell Entity Framework that I need the basket item and product inside basket item as well. So Entity Framework convert this block of code to a SQL script to include the basket items and the product inside basket item as well. This model is complicated enough. If we can manage to cache this one effectively, then we can make sure that we are able to cache any other view model with any complexity level. So let's start to introduce the cache layer. We have to make a decision where to put our cache. For this one, I will show you where output cache is set in the application and where we have to put the micro cache. You can see in this diagram, consider this is the client, and the client send a request to the server, and the output cache is set on a controller, means that the output cache is caching the result of an action inside a controller. But our micro cache will sit on the repository level between our services and repository. Because microcache is managing the whole data, any component in the system that needs data needs to interact with microcache. This is why it sits between service and repository. The first step to introduce the cache layer is to make sure that all our services are using cache layer instead of repositories. I will start with the basket service, which is the most complicated one, and then we can implement the rest as well. I will consider my cache layer as a data layer, so I will put it inside the data folder of my solution. Let's create a new project. Cache. In this project we need a class, we can call it cache provider, that connects to the cache and provide the cache functionality for other classes. I'm using Redis for my cache layer, so I need to install some NuGet packages that provides me the connectivity to the Redis. I'm using the Stack Exchange.redis. This one is one of the famous library that you can install in your application to connect to Redis. And this is about the connectivity. What about the actual server? You need this cache server. You can get it from many different websites and many different companies. Actually, at the Redis lab, they give you a free account which has a 30 megabyte free cache server, and you can use for your test application. That's very good that we test our application with the online cache server, which is not at our local server. This is very important because we want to mimic the production line. If we keep the servers at our local, then there is no latency, network latency, and other considerations. So this is the homepage of the Redis Labs. You can sign up here and use 30 megabyte cache server. Let's go back to the solution to create a cache provider. I will use this default class for my cache provider, so let's call this one cache provider. So this one should has one property which keeps the connection to the cache and let us do the operations of cache, like set any key or read any key. So I made it private static. I use lazy initialization because the cache connection is very expensive operation, and we have to make it as a lazy property. And as you know, the lazy property will postpone the initialization of the object to the demand time, not at the class constructor. Okay, because I need a connection multiplexer, I need now to install the NuGet package, that NuGet package that I show you. So I will go here. Now I can have the connection multiplexer. And I'm not going to talk about the details of this class, so you can read at their websites. They have lots of information on how to use the cache and how to do the best practice and the rest of the stuff. So I just implement that one at a very basic level. So if you need more information, please go to their website, because here our concern is the implementation of the cache layer itself. And I need a static constructor to initialize that property, the lazy multiplexer. Here I can access that property because it's static, and I can make a new connection. This class has a method called connect, and you can pass a connection string to this method to create for you the connection object. I already have my connection string, so I just copy paste my connections into one property here. Let's have another property, underline, and then this. Okay, now I have to pass this connection string to this method, so I will have that one. So I need a public property as well, because these two are private one, so I need a public property to access that connection that is provided for us. So I will make a public property. Let's call it connection, and that one will give access to the multiplexer value. Now it's time to add the cache layer, but before that I want to test the current system and find out about the capacity of the application. What I mean by the capacity is the capacity of the system to handle a certain number of concurrent users that using the system. Because if we are going to compare the system with and without micro-caching, then we need to have a proper test for that. As I mentioned before, I'm using Visual Studio load test for this purpose. Let me open this is the test that I have created for our purpose. This is a load test, and a load test is composed of a couple of scenarios. As you can see here, we have two scenarios. Each scenario will, after we run the load test, each scenario will run by a specific number of users, and you can indicate, for example, the order scenario will run by how many users. These properties will show you how many users will run this scenario, but you can also indicate a pattern for adding more user into the system, into that scenario actually. So the initial user count is 1, so it means that the test will run with 1 user. It start with 1 user, and the maximum number of user will be 20. It means that the test is not allowed more than 20 user to run the scenario. And this is a pattern that you can specify. The mode of the pattern is based on the step, and then means that in every step, which is every 10 seconds, we are adding that number of user, which is 1. So it means that every 10 seconds I add 1 user to the scenario till I reach to the 20. And what is the order scenario? Order scenario is very simple and straightforward. If I open that one, yeah, this is the test. In order scenario, first I need to log into the system, and then I need to add item to the basket, and then refresh the page, and then go to the checkout system, go back to the page, to the home page I mean, and then refresh the home page, again refresh the home page, and then place the order. You can see I mimic somehow the real scenario, that a user come to the system, add item to basket, and browse more pages, and then finally go to the checkout page and place the order. And here I have another scenario, which is admin checking basket. Is actually that page, this page that I show you, the admin can get a list of the basket regarding the states. So if I show you the detail of the scenario, here the first page of that admin basket will be loaded, and then we have different filters, which is the state, state 1, 0, and 2. Another thing is that if you get the properties of these scenario, you will get lots of other information about that scenario. If I want to delay the test, I can make a delay here in this property For example, I have a 20-second delay for this one because I didn't want to run those tests at the same time. I wanted to this one started 20 second later. So this one will start when the test started. This one is starting 20 seconds later. Okay, I'm going to run the test, but before that I wanted to change the number of the users that are running the test. Let me see. So for this one, 15 is a little bit high. I will insert 10. And this one 20. Yeah, 20 user and 10 user for this one. That's a good combination. Let's run the test. When you run the test, Visual Studio gives you a couple of diagrams that gather the information from different parts of the system. One of them is let me change that one. One of them is system under the test, which shows you the CPU and memory and other physical resources if you want. Here it gives you a couple of information about the test. For example, the red line here show you the number of the user. You can see here that the user are increasing. It starts from 1 and is increasing to 13 and is going up to reach to 30 user. As you remember, we have 20 for the order and 10 for the admin basket item. This one is also very important for us. One of the key ones is show you the page response time. These couple of columns here are important. The minimum of the page response time and the maximum and the average. And the last one. So, but I don't want to see the login, get and post, so I extract them from the diagram. Now I can see the behavior of the pages over the time. For example, this one is user basket list, the get one, the get request. You can see the line of the user is now, let me see, is it straight now? No, still is growing. So after a while it reached to 30 user and it will be a straight line because we wanted just to have the maximum of the 30 users, not more than that. But you can see here the CPU line. If there is any CPU spike over 80, it's not a good sign and you have to manage to keep it under 80-85 because application can react quite differently when CPU is in high use. But the good things is that we don't have any error so far. If there was any error, it will be appear here. The only things that is now a little bit concern me is about the CPU that is growing and going up, but still, yeah, we have here one, but it still is in a safe area. And also our response time, which is between almost 1 second to 6, sometimes go over 8, but most of the time is here, this area, which is not a good result. But you can see here our CPU is starting to react not good after our user reached to 30, but still is fluctuating. I set the system to gather the information every 10 seconds. You can increase that one to have more accurate information, but for our purpose this kind of rate is gonna be okay. So, and these other indicator is also important. It shows us the number of completed tests, so it's 102 out of 1000. I will leave the system to continue till it reached to 300, which I think is enough. You can see here at one time we have CPU over 90%, which is very critical, and the system can behave completely different at that time, at that level. One of the common mistake between developers is that when they develop an application in their local, and if the application runs without any problem, they think maybe it's gonna work at the production line, but we have always to run our application under the pressure, under the performance test, load test, to see how it reacts, how it behaves under the high load traffic, because there are some bugs, there are some poor performance under the high pressure, which is not present itself at a normal time. For example, problems like deadlock at Sql Server and memory leak in your application is happening at high pressure and high traffic. This green line, I can remove the rest as well. Yeah, this green line show me the home page, which is one of our important page, and you can see it's fluctuated between almost very low, like 240 millisecond, to maximum 8 seconds, which is very bad, this one. But the average time is 1.5 seconds. As I mentioned before, I will stop the test when the test number reached to 300, because I have enough information about the system under the 30 users. And let me bring back these kind of indicators. I'm going to stop the test after 300. I have enough information. You can see you have two critical area in the run of the test, which is not a good result. But the good things about this test, this number of users, that we don't have any problem, we don't have any error. This is not ideal result that you want your production line behave like that, because response time is a little bit high. It's not so much good. It's not good that a user wait 44 seconds or 5 seconds or even 2 seconds and 2 seconds and a half. I will run this test under higher number of users to see how system is behaving on under higher pressure. For now, it's fine, it's working without any error, but also we have two areas of criticality. And then when we introduce the cache layer, I will rerun these tests with that system, and then we have two results, so we can compare between the systems. So I'm going to stop that done. When you stop the load test, Visual Studio creates a summary report for you, which has all these information inside it. Yes, this one. So you can see we have here the different requests from different tests from different scenario. From the order we have this request, and from the admin basketage we have the other one, and you can see the requests are listed here, and the average response time are here, and the number of the total number of the test that has total number of the requests that has been run. So for example, the logging post request run 81 time. This one, because it was that page, the user basket list, ran 781. We have other information as well, like maximum user was 30, and the rest of the information you can find useful in this page. This information is saved on the system, and then when we introduce the cache and we rerun the tests again, we have all these results, and then you can compare all of them together. Now I'm going to run the test with a different setting, actually just increasing some users of the admin checking basket. Previously, when we ran the test, it was running with 10 users. Now we are going to increase that number to see how our application is behaving. So let's make it jump. Let's make it 25, which is a good number for this purpose. And let's run the test. I have to save the test first, and let's compile it again. Okay, now we can run the test. As I said before, these login, get, and post are not required because we are not changing in the both system, so I just remove them. I will leave the system to run until we reach to 300, same as before, and then we can compare the two results together. And here I make the video go fast forward. Okay, we are going to stop the system after a couple of more tests to run. We can see here that our result is much worse because we have now in the system 45 user instead of 30 user. So CPU is under the pressure a lot in many different points of the system, and the response time started here, which was good, and then it started to grow and now it reached to this area, which is more between 5 to 7.8. Sometimes it spikes a lot, but in general it's not a good result. So this was just, let me just stop the test. This was just a demonstration on how application is behaving when you add more user. Still, we don't have any exception or any error, but if we increase the number of users, definitely we will get that one. Just to demonstrate that one, I will run it again with more user for you to see the behavior of the application. So again, we have that summary. We can compare this summary and the previous one with the summary that we will get from the application with cache. But for now, let me just close this one and run the application with new setting, which gonna be let's say 50 user, and save and run. Okay, here you can see that when the user reach to high number like 60 or 50, we start to getting some errors, and the response time reached to 20 seconds for one request, which is super high. But I wanted you see how an application can behave. So now we know our capacity almost, that if our application runs with 25 user, 30 user, plus 10, it's going to be 40 user, the application can handle everything. I'm not speaking about speed. Definitely the 3 second, 4 second, 5 seconds is very bad for an application response time, but still application is working without any error. But when we have 70 user at the system, the application starts crashing. You can see we have 67 errors, and if I click on that one, you can see I have that amount of timeout error. I know that we can increase the timeout, but that's not the point. Here the timeout is genuine, and we should not let the application to reach that point. And as you have seen that our application is or CPU is much under pressure now. I don't want to wait for the test to run 300 times. I will stop it now. Just wanted to show you the behavior of the application. Now it's time to introduce the cache layer and put everything in the cache and run the test again to see how the application behave. At the first part of the video, I told you that we are going to have some persistory classes that are handling the cache and saving, updating data into the database. So, but those update data is using the repository. So I need to first let me rename this file name. So I will have some cache repository, which means that our services can access those cache repository to change data and to read data. And those cache repository will use our normal repository to get data from database and update and insert data into the database. But they are deciding that they have to go to database to fetch data or read the data from the cache. I will start with the basket, because the first thing is the basket. So I will call my class basket cache repository. So it's gonna be public, and the first thing is to have the basket from the cache. So I know that this one needs to access the basket repository, so So I need to have a method called getCurrentBasket, which is getting the user ID and bring back the current basket for me. This I will have a public method which brings back the basket. I need a reference to So this is the normal behavior of the application. If I just replace my basket cache repository with the basket repository in the basket service, and everything will work like as before, but I don't want to do that one. First I want to read the basket from the cache. If the item is not there, then I go to the database and bring back the basket. I can use the cache provider to get the database. Oh, one thing, in Redis world, you have to call a method called get database to get the database of Redis. They call it database. You can read more on their website why they call it database and how that works and the rest of the stuff. So here we have the cache and in the cache, so we have lots of methods to read many different type of data structure. You can read a hash table, you can read a set, you can directly get a key. So I'm going to use the string get, string get, which allow me to pass a key and get the value back. So I need a key for my basket. The best key is the user ID that I have. But because this user ID is just an ID, it can be, and my user ID is a GUID, so there can be other tables in the system that has GUID as primary key. So because these two keys from my table and the other table are not overlapping each other, I need to add some prefix to my key. So let's make a variable like key and do it like basket, and then we can put a dot and then combine it with my user ID. So in this way I keep my basket keys always started with the basket and dot, or basket and column, better, and I pass the key and I will get the result from the from the cache. And this basket it's gonna be a string, and I have to deserialize that one to my basket object. So the basket, I will call it and then I'm using the JSON convert. I need to install the Newtonsoft NuGet package. Dot deserialize object. So it's gonna be a basket and basket. So here I have the basket, but this basket is that comes back from the cache. I know that it doesn't have the basket item or product. So first of all I have to see that it is in the cache or not. So I will check that the basket Oh, and I need to check it before I deserialized that one. So I check that serialized basket dot, it has a property already is null, so I have to say if that one is null, we are going to read the data from the database, so it means that it's not in the cache. Otherwise we are going to read it, we are going to deserialize that one. Okay, here I can say basket equal. So now, because the object is in null in the cache, the object is not in the cache, so I go to my repository and get the current basket and bring back the basket with the username. But I know that this basket that comes from the repository no longer has the basket item inside it, basket items I mean, so I have to remove those two items because we are going to read them from the this one from the basket item cache repository, and the product from the basket from the product cache repository as well. So we no longer hit the database like that. We remove these two and we can convert that one to such a, and because it's just one line, so I can also change it like that, like this. It's much clearer now. So the basket that comes back, it doesn't have basket item, so I have to read that from the basket item cache repository, but I didn't create that one yet. So I will fetch it from the database first, and after I finish this method I will change that part to read it from the basket item cache repository. But for now I can create an empty class, so I can create a class called basket item cache repository, which has to be public and has one member, private member of iBasket item repository, so I can read the data from the database. And here I need an access to that iBasket item cache repository. So I create a member, a private member. Let me extract a interface and put it for now here. We have to move this one later. So what do we need here is that we want to fetch all basket items with a basket by the basket ID. So, and then let me again. So it's gonna be returning a get all basket items by basket ID, which takes the basket dot ID. Okay, let's generate that one, and it returns a list of basket item. This is the basket item. I think I showed you before that one. So go back, and my repository need to implement this one. In that one, for now, I just call the basket repository. So I go to database and bring back the data. I have to see that I have do we have a, so we don't have a method that bring back us all the basket item by the basket ID, so I need to create that one in the repository as well. So get all So what I have done here is that I added this method to the interface of my basket item repository. So let's go inside that one to see it has been implemented or not. No, it's not. It has not that one because we added just right now. So we implement that interface. Here we need the DB to, this is my DB context, so I have the basket item. So I need all the item that their basket ID is equal to this basket ID. It's better to rename it to basket ID. So and we say we wanted to convert that one, the result, to a list. And then finally I go to my basket item cache repository to call this one and return that one. So far we didn't do anything about the, let me see what's the problem here. Okay, return. So far here for the basket item cache repository we didn't do anything. We just make a gateway to the repository, the basket item repository. Later we have to come here and put that one in the cache as well. So we go back to our basket cache repository and yeah, we call it with the, we have here now the basket items and basket. Now we need all the products. So we say, maybe it's better to read the products in a for each, because we need for each basket item one product. So let's do that one. And here I'm going to get the product. So we need a product cache repository as well. Again, we just creating the interface and product and the body just to read the database, not the cache implementation. After that one we go to implement those two cache. iProduct cache just temporary. We add the interface. And here, if I call the product repository in for all basket items, consider I have 5, 6 basket item, and for each of them I'm going to call the database. It's going to be 6 calls. It's a lot. So I have to find a way to get all the product in one call. So for this reason, for this purpose, I can get all the product IDs and then call the repository to tell the repository we need all these product IDs. So for that one, I can get product ID like that, product IDs like basket items, select, and we want all the product ID and to a list. So I have all of that, all of the product ID. I need call the product cache repository to get all products by IDs, and we are passing the product, and so we create that one. It's returning a list of the product. And again, this one needs access to product repository. And injecting. We don't have any method that we can call and get all the IDs, all the product related to the ID, to the list of ID. So we have to say get by IDs. Okay, let's go inside that one. The product and actually where before, so, and here we have all the products. So now we have to assign these products into that basket items. So now we can make a for each loop. Because we know that the product is there, so we use the first, not first or default, and I say the ID is equal to item dot product ID. Now at this point I have a basket and basket items that has product inside it. So, but I forgot to assign the basket item to my basket, so I can do it after here. I can say basket items equal to basket items. Now here, if I return basket, the application will work like before and read everything from the database and returning the basket. But before do that one, we need to put our basket into the cache. Okay, but I'm not going to put my basket items into the cache or products into the cache, because this is the responsibility of the basket item cache repository and product cache repository. So the only responsibility of this method is to put the basket into the cache. So I'm going to put the basket in cache. So I have the cache object. So string set, or set a string set, and I have the key and the value. I have the basket, but I cannot put the basket directly into the cache because I need to put a string value into the cache. So I can convert my basket to a string by JSON convert. So let's do that one. JSON convert, serialize, basket. Yeah, that's it. So I read the basket, I put it in the cache, and then I read the basket item and products, and then I return here the basket. So what if the basket is in the cache and serialized basket is not null? So here I deserialize the basket coming back from the cache and put it in the basket. And I need to again call these process because I just read the basket, and this basket, as I explained, doesn't have the basket item and the rest. So I'm doing this. So if I have to call again these process, it's better to put it in a method. Okay, let's make a private method which returns a list of basket item and call it get basket item. I need a basket here. So let me see. I have to remove this one. So yeah, and I can return here the basket items. Basket items. Yeah, this one. And then if I fetch the basket item, I need again to assign it to the basket item of the basket. So here again, if I have the basket, I deserialize it, and then I assign it to basket item of my basket with a basket object. And I need to return the basket. Now it's time to go to basket item cache repository and product cache repository to implement those methods. Okay, let me go to this one. First, let me rename that ID to basket ID because it's not very oh, and what is this I here? So let's remove that I first. This ID is a little bit tricky. It doesn't tell me which ID is that while it is basket ID. So I change it to basket. For putting the basket item into the cache, I want to use a specific data structure in Redis called hash. We can go to the Redis Labs website to see the documentation about the hashes. But in general, if I want to give you a brief explanation of what is hash, it's a master key as a hash key, and then you can assign some sub keys which has to be unique and some values. So this structure is quite perfect for our purpose for basket items, because we have one basket ID as an hash key, and then we have basket items as sub keys and value as the basket item objects. So for this purpose, we're going back to the First, I need to have a hash key. The hash key should be generated by this basket ID. So let me create key and so you can see for every single basket we have a unique hash key which has a prefix of basket hash and then basket ID. So here we have the key. Now we can read the whole hash table. The good things about Redis is that in the database there is a method called hashGetAll, which brings back you all the sub keys and values of a hash table. So if I wanted to get all my items, I can say we have cache, and the method is hash get all. You pass the hash key, which is this one. It's better to rename this one to hash key, not just key. So this item has everything inside it. So I say if items length is greater than 0, then here I have to deserialize all the items and send it back to the caller. But we have to consider that the items that comes back from this method hashGetAll is a list of hash entry, means that it has one name and one value property. So the name is those keys and the value are the actual object that we put in the cache. So I have to use the value to deserialize that one. And now here after that I have all the deserialized basket item, so not basket, so it's better to call it basket items. So here I can return. Okay, if there is no item in the cache, so we have to fetch it from the database like that and then put it in the cache. So I need a variable, so I have to put each item separately into the cache. There is one method called hashSet, so I can use that one, which is accepted my hash key and a sub key, which is the item and ID, and then the value which I have to convert to, which is the basket item object, but I have to convert it to a JSON before put it in the cache. This is not a good approach, because every time that we call the hash set, it will take about 80 milliseconds to put something in the hash table. We have to find a way to do it parallel or to make it lower, because if I have 5 items then it takes 300 millisecond. I mean with this configuration, with the current configuration that I have, because my cache is on a server in the internet, so it takes 80 milliseconds. So if I have a basket which has 10 items inside it, it's going to be 800 milliseconds just to set my just to set my items in the cache, and that is not a good solution. I need to do it somehow parallel, and I know that hashset has an async method, so I can do it in a parallel mode. How? It's gonna be like that. So first I need a list of tasks. I know that that hash set I think will return a boolean, so I will make this one boolean as well. And I can use the for each, and I will add each of the hash set into my list of the task. So in this way, when I call an async method like that, it will start the method, but it will not wait for the method to return. One of the common mistake that some developers are doing is that they calling something like that they call this method with an await keyword like that. Yeah. Let me fix the method because it needs to be async, and also the interface. So when the .NET is executing this line, when it sees the await keyword, it will wait for the line, it will wait for the task to return and run completely, and then goes for the next line and next item in the loop. But if you want, if those results of the task are not related to each other, are not affecting each other, you can run it all of them at the same time like this, and then wait for all of them at one point. So in this way you can run them kind of parallel. So in this way, this method saying that when all of these tasks has been finished and come back with the result, then you have to proceed to the next line. So here we start to call all of these hash sets, and then here we wait for all of them to complete. And when all those tasks has been completed, so we are in the point that we have set all the cache, all the item in the cache, so we can return the basket items.